Hello everyone and welcome to this machine learning playlist. Today we are covering an important topic, so whether you're someone who is absolute beginner or you have some experience with machine learning, this playlist has been designed in such a way that it will be easy to follow for everyone. Also packed with lots of values and information, and it will be really helpful for you, especially if you're preparing for a machine learning based job role like data analyst or data scientist. So please subscribe to the channel and drop a like below to support our work, and without any further delay, let's get started with today's topic. Hello everyone and welcome back to another clustering algorithm lecture. With this video, we are going to explore the topic of DBSCAN algorithm. It is another unsupervised machine learning technique that is widely used for clustering purpose, and this topic is really important also for your interviews as well. So before understanding and exploring this particular algorithm or clustering technique, let's try to understand that when we already had a clustering algorithm like k-means clustering, then what was the actual need of developing this particular algorithm? So in the previous lecture of k-means clustering algorithm, we have already explored that how can we take a data set which is unlabeled, that is coming without any target variable, and we can use k-means clustering in order to assign clusters to these data sets. In case you have missed that lecture, then please consider checking that out. I will also provide the link of this entire playlist within this description box, so please feel free to check that out. Moving ahead, let's try to understand the limitations that is coming along with a k-means clustering algorithm, which actually leads to the need of another clustering techniques like DBSCAN or hierarchical clustering. So we can see that the cluster formed within this data set is spherical in shape. This one, or let's say this one, or even this one. Additionally, this is also not good in terms of handling outliers like these data points right here or this one right here. Of course, it visually makes sense that these data points are nothing but outliers and shouldn't have been considered as the part of the cluster at the same place. And let's try to understand, going by this picture, that how the DBSCAN clustering algorithm helps us to overcome the limitations of k-means clustering. Let's start with this first comparison. You can see when k-means clustering was asked to do the clustering for the same data set, it tried to assign the cluster in a spherical way or in a particular shape. But on the other hand, DBSCAN is actually giving us the cluster that we actually want. In the second comparison as well, you can see that how good DBSCAN is doing in terms of clustering the data compared to this one right here. So DBSCAN is a clustering technique that helps us to some extent in order to tackle the limitations from k-means clustering. Here is another example. You can see that the DBSCAN clustering is not only assigning 3 clusters successfully the way we want, this green cluster, another one is this blue cluster, and then this red cluster, but it is also really good in terms of identifying these outliers. You can see these outliers are literally the data points which the algorithm has not considered as the part of any of the clusters. So let's try to move ahead and understand that how this clustering technique or machine learning algorithm actually works. Okay, so you have a lot of things on your screen at the moment. For anyone who is new to this topic of DBSCAN, they might find it slightly confusing, but do not worry. Each and everything that you can see on your screen will be simplified within few minutes. So DBSCAN, or density-based spatial clustering of applications with noise, has these following components. So first is epsilon. It is the radius from each data point that we use to draw the boundary or the circle. So each and every circle that you can see, its radius is called to be the epsilon. Second is minimum points. It is the minimum count of data points that we want within our core. In simple words, any circle with minimum points, for example, we are considering 4 over here, will be defined as core. So you can see this particular circle has more than 4 data points. This particular circle has more than 4 data points. However, this one and this one and this one as well has less than 4 data points. This is why these 3 cannot be considered as core. Then we have defined core. It is the area with minimum number of points that we have defined earlier as 4 over here, for example. And we have already seen that how these 2 circles, this one and this one, are the core in this example. Then we have red data points. Simply these are the data points within the core. So all the data points within this circle and this circle will be termed as red data point. For your convenience, I have also color coded it in red so that it becomes easier for you to understand. And the next is yellow data points. These are the data point with at least one core point inside the circle. Try to observe these two circles, this one right here and this particular one right here. One common thing about both these circles are both of them have a red data point inside their boundary. You can see here and here. But how is it making sense? The logic is if we have even one red point within our circle, then that particular circle or the other data points within that circle would not be identified as outliers. And the last one is the blue data point, also referred as the noise or outlier with no other data point inside its circle. For example, this one. This particular circle has a blue data point which is not intersecting with any of these cores, and it does not have a red data point inside its area as well. So in simple words, core or the circle with minimum data points will be identified as high density cluster, where the density of the data points is comparatively more. The yellow data points or the circles with yellow data points, which is defined by having minimum one red data point inside its circle, this is identified as the low density cluster. However, the circle with blue data point will be identified as outlier. So previously in the lecture of k-means clustering, we have seen that how outliers impact the algorithm a lot, and that was one of the limitation of k-means clustering. But you can see this particular clustering algorithm, DBSCAN, is really well in terms of handling outliers or differentiating high density cluster with a low density cluster. And this is the core idea around DBSCAN. Let's quickly talk about the advantages of this particular algorithm. Of course, there is no need to specify the value of k for the number of clusters the way it was required in k-means clustering. It is able to identify noise data while clustering, works very well in terms of identifying the noise or outliers, and it can discover the clusters of different shape and sizes. Exactly the opposite we have seen in k-means clustering, that discovers cluster only in spherical shape. So that is no longer a limitation with DBSCAN. Talking about the disadvantages, the algorithm does not perform well in case of varying density clusters. So let's say if you have different clusters in your data set where you have too much variance in the density. So in the first cluster, you have too many data points, like more than 50, 60, 100. And in the other cluster, let's say you have only 5 or 10 data points. Then it will tend to identify the cluster with low density as the noise or outlier. Second would be it fails in case of neck type of data set. So I'll try to explain what that is. So this one right here, the image that you can see, this particular data set is an example of neck type of data set where there is no marginal difference between two clusters. It has few data points creating a neck between two given clusters. And this is one of the scenario where DBSCAN has some limitation. And lastly, it does not work well with high dimensional data. So if you have too many features within your data set, then again the performance of this particular clustering algorithm will start declining. Okay, so I hope that now your understanding around this topic is pretty much clear. If you still have any questions related to it, feel free to drop your questions below in the comment section. I will try to respond as soon as possible. Thank you very much for your time today. See you in the next lecture.